Let's shift our attention now to solving problems with half-lives. Let's look at problem 1 in slide 20. The radioisotope strontium-90 has a half-life of 38.1 years. If a sample contains 36 milligrams of strontium-20, how many milligrams will remain after 114.3 years? Okay, so I know that one half-life for strontium-90 is 38.1 years. Now, I've been given a time of 114.3 years. So 114.3 years. I first have to figure out how many half-lives have passed in 114.3 years when one half-life is equal to that. So I can do this, where I can have one half-life is equal to 38.1 years. My years will cancel, leaving me with 3 half-lives. So 3 half-lives have passed in this total time. Now if I start with the initial amount of 36 milligrams, how many will I have left after 3 half-lives have passed? And this is how I do it. Now, if you have a different way, that's fine. But if I start with 36 milligrams, after my first half-life, I will have half of that. That's the definition of half-life, is the time it takes for the half of the original amount to decay. That means you have half of this left, which means you will have 18 milligrams after the first half-life. Now, I have to have 3. I only have 1. Let's do another one. So my second half-life has passed. This is going to be halved again, which means 9 milligrams. But I have 3, which means that I will have another arrow. So that's what I tell my students, count your arrows. 1 half-life, 2 half-lives, 3, which is my last one for this. 3 half-lives, I will divide this by 2 once more, and this will be 4.5 milligrams. And that is the amount that I will have left of my strontium-90 after 114.3 years have passed. Okay, that's problem number 1. Let's look at problem number 2. Iodine 123, used in the treatment of thyroid, brain, and prostate cancer, has a half-life of 13.2 hours. So one half-life is 13.2 hours this time. Not years. We don't want that stuff to hang around our body for years. We want it to be gone in a short amount of time. How much of a 64 milligram sample is left after 26.4 hours? So I have 26.4 hours. Once again, this is my total time. I have to figure out how many half-lives are in this time that has passed. I can use this as a conversion factor, which 1 half-life is equal to 13.2 hours. My hours will cancel, leaving me with 2 half-lives. So 26.4 hours, when those pass, I have 2 half-lives left that have been gone. So if I start out with 64 milligrams, how much do I have left after 2 half-lives? Well, let's do arrows. My first half-life, I will divide this by half because that's the definition of the half-life. 32 milligrams. But I need 2 half-lives to pass. So I have 1 more. So 2 half-lives. I will take this and divide this again, and this will be 16 milligrams. And after 2 half-lives, or 26.4 hours, you will only have 16 milligrams out of that initial 64. Okay, I will erase this and then we will do the last 2 problems. Okay, let's take a look at the last 2 problems. Iodine 131 is used to image thyroid tissue to determine the presence of thyroid cancer. Iodine 131 degrades through a beta decay followed by gamma mechanism. Write the decay equation to determine the final product. Okay, so we have iodine 131, which means it's this iodine 131, and it's element number 53. And we're not going to really worry about the gamma radiation, although the gamma doesn't, it's a radiation, but it doesn't change. It has a 0 mass and a 0 charge, so it doesn't really change any of this, but I'll show you what to do. It also tells you that it undergoes a beta decay, and we know that this is my beta particle. Okay, so let's write the final product. Remember, beta decay increases the Z by 1, so it's going to be 53 plus 1 is going to be 54. And then the top number doesn't change, 131. And this element number 54 is xenon. And then plus another gamma, I should do it this way, a gamma, and I'm not very good at writing gamma, but it looks like that with a 0 and a 0. And it's still going to be 131 xenon 54. This doesn't change any of it because it doesn't have a mass and it doesn't have a charge. Okay, so this is your final product. The half-life is 8 days. So 1 half-life is equal to 8 days. If you need a solution with a total activity of 3 millicuries in 24 days, what should the initial activity be when it's made? Okay, so at the end of 24 days, it's telling you that you want the activity or the concentration to be 3 millicuries. What should it be at the beginning? So the other 2 problems, we started with the amount and then we figured out how much it was left at the end after several half-lives. Here it tells you after this half-life, this is how much you have left. How much should you have at the beginning? Should you start with to have this amount? So the days that have passed are 24. So let's convert those to half-lives. 24 days. This is my conversion factor here. Okay, 1 half-life is equal to 8 days, which this, if you do this, it gives me 3 half-lives. Okay, I don't know what that is, so I'm going to put X. So I don't know what I should start with. X millicurie. Now, after my first half-life, I will have an amount. After my second half-life, I will have another amount here. And after my third half-life, it tells me that I should have 3 millicuries left. Okay. Now we're working backwards. If I'm left with 3 millicuries after my third half-life, before the third half-life, I would have double that, which means I would have 6 millicuries. If I have 6 millicuries after my second half-life, before it, I would have had double, which meant this would be 12 millicuries. And then after my first half-life, I would have 12 millicuries, which means that at the very beginning, I should have started with 24 millicuries. Once again, do this. You have to have 3 half-lives, 1 arrow, 2, 3 arrows, right? If I start with 24, divided by 2 gives me 12. After first half-life, after the second, divided by 2 is 6. After the third, divided by 2 is 3. And he tells me that I need to end up with 3, which means that I have to start out with 24. Okay, let's take a look at the last problem. This is problem number 3, and let's look at problem number 4. Fluorine 18 is used in PET scans. An initial sample of fluorine 18 of 360 milligrams after decaying for 550 minutes was found to be 11.25 milligrams. What is the half-life for F18 or fluorine 18? So now we're starting to work a little backwards, okay? So it tells us that we start with 360 milligrams. And we end up at 11.25 milligrams. So let's see how many half-lives will pass until I hit 11.25 milligrams. So after 1 half-life, I will divide this by 2. I will have 180 milligrams. After another half-life, so 2 half-lives, my second half-life, this will be half, which is 90 milligrams. After another half-life passes, so my third half-life, this will divide in half again, so it will be 45 milligrams. After, and I'll continue here, after my fourth half-life, this will be divided by another 2, which will be 22.5 milligrams. And then I'm still not at 11.25. If I divide this, so if I take another half-life, my fifth half-life, and I end up with 11.25 milligrams. So to start out with 360 and end up with 11.25 milligrams, 5 half-lives have to happen. So 1, 2, 3, 4, 5 half-lives, okay? Now, those 5 half-lives have to equal, basically, they have 550 minutes, because that's the whole time, the time that has passed through for the initial sample of 360 to get down to 11.25. It tells me that after decaying for 550 minutes, you found that you had this much. So 5 half-lives equal 550 minutes. So I need to figure out what 1 half-life is, okay? And 1 half-life is 550 minutes, 50, not 15, divided by 5 half-lives, and it will be 110 minutes. So 1 half-life is 110 minutes. 5 half-lives are 550 minutes, and I go from 360 milligrams all the way down to 11.25 milligrams after 550 minutes have passed. Okay. This concludes the problems on the half-lives and concludes actually the problems for Chapter 20. If you have any questions, please don't hesitate to ask.